Viewers, we are in our virtual machine Ubuntu. So let's open the folder. So we have NS all-in-one 3.37 in downloads folder. So following the general, you can say the protocol, let's open the terminal from the NS 3.37 folder and let's check out that what we have inside the scratch folder. So we have my first.cc, my second, my third. Okay. So now we need to make ring topology, right? Which is the customized scenario that we have pretended that we are going to make the ring topology with the 4 nodes. So we are going to utilize the first and second.cc file. Okay. So we have copied first.cc file and from the examples slash tutorials slash the folder whatever we have seen up till now, and rename that file, and which is the file is my first.cc. Okay, so we are going to copy cp./scratch my first.cc file, and we are going to paste that file inside the same folder, and we rename that file to ring.cc. Okay, now we just open that file inside the scratch folder. Okay, so now we just remove this. We also don't need this default network topology for generating the PCAF, for generating the animation, or you can say the .xml file. We need to import NetAnim module, and okay, which we have already included the NetAnim module .h header file. So we need to include NS3/mobility -module.h. Okay, so this we need to keep as it is. We don't need. Okay. So now we need to change some parameters, and the ring topology will be ready. So the first thing, nodes. As you can see, we are generating 4 nodes over here. 2 nodes over here. But for ring topology, as we have said that we need to utilize 4 nodes. So we need to create 4 nodes over here. And as we can see, as we have seen in previous explanation, that we are going to make 4 point-to-point links, 0 to 1, 1 to 2, 2 to 3, and 3 to again 0. Okay, so let's group the nodes. Node 0, 1, node 1, 2, node 2, 3, and node 3, 0. And let's now node 0, 1. Let's now add the already created nodes, which are at nodes dot get 0. So what we have did, from the nodes, we have created nodes 0, 1. We have created 5 aliases, 4 for the individual links, and 1 the alias which is containing all the nodes. So first we have grouped all the nodes. Then from that all nodes we are grouping the nodes. So 0th nodes we are putting inside the node 0, 0, 1. Then we'll put first node. Okay. Now we need to copy these 2 lines. Okay. And now we need to paste these lines 4 times because there are 4 nodes. So now node 1, 2, which is group of 1 and 2. The node number 1, I am talking about the indexes. Okay, so don't get confused. So 1 index and 2 index. Now node 2, 3. which is the group of second index node and third index node. So we are going to paste it over here, second index and third index. Now third index and 0th index. So the third index node from the all nodes which we have created over here, which is at 0th index of this alias node 30. So hope you are getting that why we have grouped the nodes over here. So let's give the comment, creating nodes and grouping them according to link. Okay, now we need to make link. So let's again write first of all comment, making link. Let's keep the link generalized, which means all the links will have same device attribute and channel attribute. So data rate will make the as realistic topology as possible. So let's give 100 Mbps and delay, let's say it is 2 milliseconds. Now we need to make devices. So making devices, we need to write, let's just write comments. So the devices, we don't need generalized device. So let's create device 01, devices 01, devices 12, devices 23, devices 30. So according to link we have created devices, okay, 01, 12, 23 and 30. So devices 01, we are going to install the link, okay, and we'll use node, not nodes, we'll use node 01. Okay, so node 01 are considered as devices 01 and we are installing the point-to-point link which we have created over here. So same way we'll copy this line, we'll paste it 3 times again, and now we just need over here 1, 2, and over here node 01 in place, node 1, 2 in place of node 01. Similarly 2, 3, 2, 3, 3, 0, 3, 0. Okay, so that's it, we have created device. Now we need to install the IP stack. So as we have talked earlier also, that IP stack will not change according to devices or according to machine. So we can use this as generalized. So installing IP stack, internet stack helper stack, stack.install and nodes. So nodes and nodes, which will install the IP stack on in all the nodes. Now IPv4 address helper. So this we need to create. So first of all we need to create interface, and in the interface we need to use this base address. Okay, so first of all for devices 01, between 0 and 1 there is a network which is 54.0.0.0 and the /8 network, which is net subnet mask is 255.0.0.0. Okay, so this line and this line will be grouped. So for all 3 links we need to copy and paste these 2 lines. Okay, and we need to change interfaces 01, interfaces 1, 2, interfaces 2, 3 and interfaces 3, 0. Also we need to change over here 1 to devices 2 3, devices 3 0. Also we need to change the network from 54 to, let's say we go numerical order, so 56 and 57. Now we need okay, so let's just write comment over here that what we have did. So assignment of IP address. Now configuring server. Port number is 9, server apps. So from over here we can take from the general nodes that from the all nodes the 0th index node will act as a server. Start time is 2 seconds, stop time is 10 seconds. Now client configuring client. Configuring client. So interface is over here 0 1, get address of 0 and port number is 9, next packet, okay. Now client apps, so the client will become the index of third node. Okay, now start time is 1 second, okay, and stop time is 10 seconds. Okay, now to generate the routing table entries, so that there are 4 different networks, so packet can transfer in all the directions without you can say the routing facility is impossible. So we need to ensure that we have routing facility. For that, from the second.cc, remember to copy and paste this line IP for global routing helper and populate routing table. Okay, so which will populate the routing table and we don't need to worry about the routing of the packet since there are different networks, so it is required. And now to enable the packet capture and what we can say the net file, we need to generate .xml file to observe the animation. Okay, so we need to just write 2 lines. The first line for generating the .xml file for the observation in NetAnim, we need to write animation interface, let's say anim, the alias name, and the file name, suppose ring topology .xml, and the link which is point to point that we have created over here. So let's just copy and paste the alias name and dot enable pcap all, which will enable the packet capture for all the links. And now let's say the alias name, or we just open the second.cc file and we just see the syntax. So the syntax is just we need to give the name, let's say ring pcap all. So that's it, we have created ring.cc file which will generate the ring topology with the 4 nodes. Let's just test it. We do not close, let's go to terminal and let's run the file NS3 run and ring. Let's see what happens. So it is generating the target, or you can say object file, then it will compile, then it will run. So yeah, you can say that there are 1, 2, 3, 4 and 5 requests are thrown, and you can see that 1 second and 2 second requests are not received because server has started 2 seconds and client has started at 1 second. Okay, so that's the observation from the previous videos that we have seen. But after 2 seconds, all the packets got replies. Okay, and also if we go inside the NS 3.37 folder, so see packet capture for all the files ring 00, ring 01, ring 101130, all the link has generated the packet capture file. Now there is a ring.xml file, so let's open it in NetAnim. So for that we need to go one folder backward, and from the NetAnim folder we just need to fire the /netanim command, which will open the NetAnim application. Now just we open that file over here, ring.xml, and now let's see the animation. So you can see simulation has been completed. Or we can open the ring topology file, ring topology.xml. Okay, over here. So this is the reply of first packet. This is second. This is third. This is fourth. This is fifth. So you can see the simulation has been completed. So that's how you can reuse the same code of, you can say, the first.cc file, and you can make any topology. So in upcoming videos we'll also explore the mesh topology and variety of different topologies from the scratch. So you might have gained the basic general idea of how to make the ring topology, or you can say the any customized topology. So that's it for today's video. We'll see more on this in upcoming videos, but today let's keep it over till here. We'll meet in the next video. Till then, keep learning and keep exploring.